Stat students, welcome to Inference. And today we are going to be creating a one proportion Z interval. Now let's look at the example. It says your local newspaper polls a random sample of 330 voters, finding 144 who say they will vote yes on the upcoming school budget. We are going to create a 95% confidence interval for the actual sentiment of voters. So the big difference here between the problems we worked on last week and this one is that we are not given P. We are not given the true proportion. So the goal of a confidence interval is to give a good idea of where that proportion actually is. And the first step is to define our parameter. And the parameter for this problem would be the true proportion of voters who will vote yes on the school budget. That's what we're trying to find. Next, we check the assumptions, and this is similar to what we did last week. The first assumption is that this is a random sample, which it did say so in the text, so yes, that condition is met. Next, the 10% rule. 330 was our sample size, and we have to ask ourselves, is that less than 10% or 1/10 of all voters? And we're going to assume this is a fairly large voting area, well populated, and so we will just make that assumption that there are more than 3,300 voters. And then the success-failure condition. We know that N, our sample size, is 330. We do not know what P is, so the best we can do is our P hat from our sample. And our proportion from our sample was 144 out of 330, which works out to as a decimal of approximately 0.44. And so we multiply N, 330, times P hat, 0.44. And is that going to be greater than or equal to 10? And you do not need to calculate the number exactly, but yes, that is going to be a number that is going to be greater than 100, so obviously greater than 10. And then our sample size, 330, times our Q hat, which is just 1 minus 0.44, so that's going to be 0.56. And is that going to be greater than or equal to 10? Well, that's going to be a bigger value than N times P hat. So yes, that's going to be greater than 10 as well, a number greater than 100. So we met the assumptions, and now we need to name the interval. And for this particular case, it's going to be a one prop Z interval, one proportion Z interval. We took one sample, one proportion. We are going to be using the normal distribution for a confidence interval. And so that's where the Z comes from. And yes, this is going to be an interval, not a test. We'll get to the test later. So now we actually have to give what the interval is. And remember, it is a 95% confidence interval. So the Z star, which we're going to be using for 95%, is 1.96. And that tells us the number of standard deviations on either side from our P hat. And then we multiply our Z star times the standard error. So the interval is going to be our point estimator, P hat, plus or minus Z star times the standard error. Now to get the standard error, we take the square root of our P hat times Q hat over N. And this formula should look familiar to you as the standard deviation for a proportion, but it is the standard error because we're using p hat and q hat and not the true proportion. So it's going to be 0.44 times 0.56 divided by 330, and then you take the square root of that value. You should get something approximately close to 0.03. So now we have everything we need to give the interval p hat 0.44 plus or minus 1.96 times 0.03. So the left-hand limit of our interval is going to be 0.44 minus 1.96 times 0.03, and should get approximately 0.38. And then the right-hand limit of our interval is going to be 0.44 plus 1.96 times 0.03, and that gives us a value almost exactly 0.5, almost exactly half. So now that we have our interval, we can write our conclusion. And if you did a good job writing your parameter in the beginning, the conclusion can be written really easily, giving appropriate context. So we are 95% confident that the true proportion of voters who will vote yes on the school budget lies anywhere in between 0.38 and 0.5. So you can get a sentence frame out of this for any conclusion. We are the percentage of your confidence interval, the parameter that you wrote at the top lies anywhere in between the two ends of your interval. So the more practice you get with these, you'll notice PANIC, panic. So in our class, panic is a good thing. That means we know how to properly write a confidence interval. And the more practice you get, just the more comfortable you will feel.